All right, so we're working with ISBN.xlsx from today's day in the schedule. Go ahead and download that and open it. I'm going to skip by this for a second. Let's do a thought experiment. Let's pretend it's the 70s. Everyone should get an afro and wear bell bottoms and a floral print shirt, belly button with your unbuttoned your belly button, and then you'll be in the proper mood for this. But suppose that you are manager of a bank. It's the 1970s, and for 100 years, your bank has kept its records on paper. And now you're thinking, maybe these computers are not just a passing fad, and we're going to need to buy a computer and use it to record stuff. Okay, so why am I setting this in the 1970s? In the 1970s, there are two things that are really different. Well, there's a lot of things different about computers. There's no mouse, by the way, in the 1970s. But two things are really expensive in the 1970s that we don't think as expensive today. And one is network traffic. So being able to communicate to another building or another place in the country, today that's cheap and fast. In the 1970s, that's expensive and slow. The other thing that's expensive is accessing information from a disk. So saying, I want to read information from this disk and then send it back to the user as kind of part of the process. Those things are expensive. And so our task for this moment is to design the screen that we're going to use to be able to input a cash deposit. So someone's going to walk in, say, I want to make a deposit. There's probably a deposit slip. We'll fill it out, with my account number and whatever. And now we are ready to collect it. The teller now is looking at the screen. It's a blank screen, by the way. There's no mouse. There's no lines. It's just, we got to decide what to put up. We got characters to work with. That's all. What do we need to have on the screen to be able to handle this data entry? To be able to deposit cash into an account. What information do we have to collect? Account number. So we'll just put in here a account number. We'll probably abbreviate it because we only have 80 characters wide to work with on the whole screen. So we've got account number. We've got some place to indicate that we're going to have the account number. And of course, it would just be, again, characters that we have to work with here, but I'm going to put like a frame, a border around that. Is that a thick border? Okay, account number, what else do we need? Routing number is part of the account number. But, we can split it out. Okay, let's split it out. Routing number. You said it. It's a good answer. It's one of the I was thinking of, but I'll put it up there. Boom. What else we need? The amount. Right, account number, routing number, amount. That's it. That's really all I need. Routing number. We need a routing number. We just realized, why not? It's not a check. It's cash. There's nothing to route here. Just tell me your account number, and we're going to put it. Even simple. Two things. Account. Okay, so here's what's going to work. Someone's going to come in. It's a $100 deposit. They're putting in $100, and they're typing the account number. All right. Now, what's the risks? What are the potential hazards here? That's the big one. Sending it to the wrong account. So, how are we going to? We got to figure out how to solve that problem. How are we going to make sure that we're not sending it to the wrong account? It's 1972. What do we do?
I'm going to look up and find the name of the person.
Aha! Let's take that account number. Let's send it back to the database, which is maybe in a different town. And we're going to bring back the owner of that account, and we're going to say, good day, Mrs. Johnson. I'm not Mrs. Johnson. Oh, well, then we must have the account number wrong. We'll fix that, and we'll check that again. That's a really great solution today. But in 1972, that is a really expensive solution because the two expensive things, data access and data transmission, it uses both of those things. I want to avoid that.
I might even put in another field for names so that I don't have to do it once. I just send my data, and then it checks within the server. If it doesn't work, and it'll just go through and not send anything back to me. It does.
Okay, so you're trying to help it a little bit. We're sending it, and then we only get it back. I like that. So that's was by Nikki. Ever since she was in 3rd grade, and her teacher read to the class the book Veronica and the Hippopotamus. Since then, she has not gone by Veronica. To make matters worse, when her parents named her Veronica with 2 N's in the middle. Really unusual spelling. This is the problem, right? Because what's your name, Nikki Allen, and that's not going to hit. Oh no, it's Veronica, and that's not going to hit. And so yeah, we're looking for a different solution. Other thoughts?
Well, you might not be able to.
Hold on a second. What's that?
Is that true?
That's true. All that stuff I said is true.
I said you might not be able to make it where you can see if it's a specific correct one, but you can set up the account number in a way where it's if it meets this form.
Tell me more.
Basically, it's it wouldn't be an account number if it doesn't It's
our account numbers are 12 digits long.
Yeah.
And something else. Yes, that's the solution that we came up with. Let me tell you what the first step into this was. What we said was, we're going to look at this and say, okay, there's the account number. That's enough to uniquely identify the account. But we're going to add a couple more digits onto it. So let's just add these digits up together. That looks like, well, that's 20. So there's 10, and there's 9, and then 1, so that's 20. So what I'm going to do, the sum of those digits for the account number is 20. And so I'm going to actually make my account number, say 20. The account number is 1524820. So now I can tell if it's typed in a valid account number without doing any data lookup or any data transmission. I can just do some really simple math right on that. Take the last 2 digits, set them aside, sum up all the rest of the digits, and see if those 2 things equal each other. It's called a checksum. And it's a brilliant, brilliant idea. Because now, if I make a mistake in the first half of if I change any one of these numbers here in the first half, for that to be even a valid number, I would have to make the corresponding mistake here. The likelihood of doubling that up is extremely low. I would have to make 2 mistakes to be able to get to another, to some valid wrong address. This is really pretty good, yeah.
Isn't that solution only make sure that we deposit it into a valid account, not necessarily the correct account?
That's true, yeah. So what we're saying is that, hey, remember it's 1972, and we can't have the whole world for us. So it's going to make sure that we've got a valid account, and it's going to dramatically reduce the probability of getting an invalid account. I mean, dramatically. And so, yeah, there's still maybe errors. There's room for errors here. And there's still room for errors in the other approach that we had proposed, because then information could come back and the teller could be like, yeah, whatever. It looks like the same thing. And move on. So as long as we've got humans involved with the computers, there's possibility for errors. And so this is the solution that we came up with in the 1970s. Now, so it takes 2 mistakes to be able to get to another valid account. How do you feel about it? Feels pretty good. There's one big problem. Go ahead and say it. What's the most common mistake? I think you probably are on it.
You just switch your...
That's right. If I transpose any 2 numbers in the first block here, they still sum. The order isn't important. So this account number has the same check digit as this account number does. And that's the most common mistake. Transposition to sequential digits. And so... What was that?
It's just a great phrase.
That's right. Transposition to sequential digits. That's the most common keyboarding error. And this approach doesn't protect against it. So it didn't take us very long to figure out that a checksum by itself wasn't enough. And so we said, aha, we're going to come up with a check digit. Check digit, then, is a more sophisticated algorithm than just summing up the digits. It's going to be like this. Take the first digit and multiply it by 4. Take the second digit, cut it in half, round it up to the next whole number, and then add 3. Take the next digit. So we're going to think about some algorithm that will produce something that will protect against these situations. Number 1, any single number being wrong, and the check digit won't be right. Number 2, any 2 sequential digits transposed, we want to make sure that that doesn't produce anywhere there. That doesn't. And in fact, if we can get it to where any 2 digits transposed, sequential or otherwise, that's a bonus. If we can say these are the most common things that happen, and if we can prevent from accidentally coming across another valid account number that way, we'll feel pretty good about that. And if we can lower it down to only needing to have to key in an additional digit, here it takes 2 digits. But if we can get down to only having to add 1 additional digit to the account number, we feel really good about it. That's why it's called a check digit. And they are really common. They're everywhere. In fact, one of the places that you see them By the way, anytime you've got a product number, like looking at like a SKU number, there's a check digit in it. It's not necessarily the last digit, but somewhere one of those digits is a check digit. Let's look at let's just look at a picture of an ISBN. Images. I guess saying ISBN number is redundant because the N in ISBN stands for number.
ISBN is barcode number?
ISBN is the International Standard Book Number, and they actually had ISBNs before they had barcodes. And so if we look at here, so here it is, here's the ISBN. In fact, it's a different, so what we have down here is a product number. This is probably 13 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is a product number. Product numbers, like the EAN product number standard is 13 digits. ISBN numbers started out as 10 digits, but then about 5 years ago, maybe more now, they switched to 13 digits. They said, you know what, why don't we take ISBN numbers, let's add 3 digits on the front that just says, this is a book. And then the ISBN number, and then the ISBN is also the product code. It's the same number, whether it's the ISBN or the EAN product code. And so that's, so now if you look at your book now, if you look at the code on the bottom, you should see it'll say an ISBN, and the product number that's underneath the barcode should look the same. Should be the same. Are they?
Actually, this is a rental, so they covered it up for me.
Oh, yeah.
So I can't tell.
Anyway, all right. So in this case, the ISBN is kind of it's one of the older standards that we still use today that has a check digit. This idea of having a check digit is part of it. So if we look at this, the last number is the check digit. In fact, if you've got a book that's probably about 4 or 5 years old, it's pretty common to actually have a 13-digit ISBN and a 10-digit ISBN listed both side by side. And you'll notice the middle of those are exactly the same. The check digit on the end is different, and then the 13-digit ISBN has 3 digits in front of it. But then the rest of those numbers are exactly the same, because it's the identifier for the book, and then the rest of it is just window dressing. So what our goal today is, it is to be able to write code, actually write a function. We looked at functions last time we were together, built-in functions. Like we used a function like instring. Someone tell me what instring does. It's a built-in function, part of the VBA language. INSTR. What does it do?
It finds text within text.
It looks at a string for the occurrence of another string. Tells you where it finds it, right? That's what a function is. You call the function, you pass it some information, the function does some computing stuff on it, and when it's done, it sends you back some information. So in this case, if we're doing in string, we send it a string, we send another string, we tell it where to start looking, it does what it does, and sends back a number. It says 7. That string occurs in the inner string at the 7th position. So what we're going to do today is we're going to write our own function. And the function that we write is going to validate a 10-digit ISBN. We're going to pass it a purported ISBN, a claim. Someone says this is an ISBN number, and what we're going to do is we're going to run the math on it and see, is it a well-formed ISBN number? Will we know if it's a real ISBN? No. All we'll know is if it's well-formed. Now here's the thing. ISBN, the last digit is the check digit. And when this standard was written, the best we could come up with, we tried and tried and tried to figure out an algorithm that would satisfy all the needs for a check digit, meaning there's one digit, any digit being wrong we can catch, any 2 sequential digits being transposed we can catch. We couldn't do it. We just couldn't figure it out. Not without being overly complex. And part of this is people got to be able to implement this in computing code. So we don't want it to be too complex that people are going to make mistakes in the implementation. And so instead of having it with just 10 different values for the ISBN, the closest we could get was 11. 11 different values. And with that, we then said we've got to be able to represent that still in one digit. We're pretty good. We can use 0 through 9, that gives us 10. But now we want to be able to represent 10. When the algorithm produces a 10, we want to be able to represent that with a single digit. How do you do it? How do you say 10 with one symbol?
X.
X. Why X?
Because X is the Roman
numeral for 10. X. X means 10. And so that's what it is. If you look at some ISBNs, you will see that they have an X. That's .ISBN. check digit. If we apply the algorithm to the first 9 digits here, it produces 10, and that is Roman numeral 10. So you will never see 10 in a 13-digit ISBN. 13 digits, they've got a way to, for all those 13 digits, to satisfy all the needs for a check digit and still get it down to just 10 symbols, 0 through 9. So that's what we're going to deal with. Today. Anything else about that? That's it. You ready to do it?
Yep.
Oh, hey, one more thing. That doesn't really have anything to do with what we're about to do, but it's just kind of fun. And since this, the guy I'm going to talk about was a former colleague, although he worked here at BYU before my time, I'm going to do it. Who can tell me, did we talk about Frank Abagnale Jr. in this class? I have a sense that I might have mentioned him.
No.
The guy from Catch Me If You Can.
Yes.
This was his first financial instrument fraud. His first fraud actually dealt with credit cards. He would buy stuff on a dad's credit card, and then he would sell it back to the place he bought it for cash. That didn't last very long. He got caught pretty quickly at that. But this one was really ingenious. He realized, I mean, most of you probably don't even have checkbooks anymore these days.
Yes.
How many of you have a checkbook? Oh, like half. That's pretty good. So he realized that people come into the bank to deposit a check. They don't have their checkbook with them. If they had their checkbook, they would have deposit slips in the checkbook. But right there in the counter of the bank, there are a bunch of what they call counter deposit slips. It looks just like a deposit slip, like the one you have in the back of your checkbook, except it doesn't have your account number. There's a place to write your account number in. Well, he realized that most people don't write their account numbers in. They would go in, they would write their name onto the name, address, it's all there. They would take it up to the teller, and the teller would look their account number up. All right, Mrs. Jones, we're going to look up your account number. Very good. What's your account number? What's the account number? But if they put the account number on, the teller would just key in the account number. Key in the amount, the account number, deposit check, and move on. He walked into the bank. He picked up a stack of those deposit slips, took them back to his home, to his typewriter, typed in his account number on all of them. Took them back to the bank, put them on the counter. When Edna came in to deposit her Social Security check, she took it just like she's done for years. She took that account, or that deposit slip, she put in her name, her address, the amount of the check, whatever. She goes to the teller looked at it, and she typed in the account number, deposited that check right into Frank's account. After 2 weeks, he closed the account. Withdrew the money and disappeared. And then he got a job at BYU. The university, by the way, denies that. I don't know if it's true.
Wait, he actually did that? Like, this is real?
What I just said?
Yeah.
That is real. That really happened.
Wow.
Yeah, I didn't make that up.
Sound like a movie.
I watched the movie.
They don't talk about this part in the movie. They do talk about it in the book. He does. Yeah, he came and got a professorship at BYU. You know, if I'd have read the book before I was a professor here, I would have thought, it's a lot less expensive. You know, just come and pretend you're a professor, then go and get a PhD or whatever. Okay. So let's go ahead and take a look. All right, open up your Visual Basic for Applications editor. Let's see. Oh, you know what? I think we opened this as an XLSX. That means there's no code in it, so let's make sure that, let's go ahead and insert a module. Oh, hey, before we insert, let's just make sure we do this. Everyone do this with me. If you haven't done this already, now's the time to do it. You're in your Visual Basic editor. Choose Tools. Options. Tools, Options. And let's make sure that you've got Require Variable Declaration checked. If you uncheck this first one here, Auto Syntax Check, that will make it so that you don't get nagged with a dialog box every time you have a syntax error. That's nice. Take that one off. Oh. But this one, you want to make sure you have this one checked. That will make it so that when you create a module, insert module, it automatically starts with this option explicit here. Option explicit says, if you're going to use a variable, you have to define it. It's going to prevent you from accidentally misspelling a variable name. I think we talked about this before, but anyway, let's make sure that we're to that point. And then I'm going to go ahead and save this workbook. Documents, I'll call it ISBN_13. Make sure that I save it as an XLSM. That was the whole point. See if we can save the macros. Okay, so now what we need to do to be able to create a function, we used functions that were built in, part of the VBA language. We are now going to create our own functions from scratch. And we're going to make two. We're going to write a function on the way to be able to solve this first problem, but let's go ahead and declare our first one. typically when we write code, we start with the keyword sub. That's short for sub procedure. We're not doing that today. We're going to start with the keyword function. It's short for function procedure. But then we give it a name. Let's call it isValid ISBN 10. IsValid ISBN 10. Now, open parenthesis. You remember that when we call a function like length, len, and we pass it something, here's where we're going to set up the ability to receive something into this function. We're just going to declare a variable right here. I'm going to call this the candidate. Candidate. As a string. So we are establishing that when you call this function, you've got to tell us something to work on, and we will receive that value into a variable called candidate. So we'll be able to work with that value that's sent in through that right there. Question?
Yeah, is there a reason why once you type in function, it won't let you press space after it?
When you type in function, it won't let you press space. Stand by for a second. Let's do one more thing, and then I'll explore that. We will then say as, and then we give a return type for the function. Right? Just like if we're declaring a variable name as some type, the function has some type too, and it's the same kind of types. It's the same set of data types that we use for variables and for functions. So what data type should we return?
Doesn't it need to return a digit? Check
You could do byte.
Oh, just
We could send back a byte, just some number between 0 and 255.
or just Boolean.
Could be a digit if we're going to send back the check digit, but the way I'm envisioning this is that you're going to send the whole ISBN, and we just want to know is it valid or not. And so we just want to send back a yes or no, or instead of yes or no, a Boolean, a true or false. And so the type of this would be Boolean. Okay, now we had a question from the top row that said, were you typing in a function like this?
It won't work for sub either. Like my text just turns red.
Sub, you hit space and the text goes red? Jaron, can you help us with this? Yeah. Let's go take a look at this code and see
Sorry to interrupt.
what's going on. Something's hinky. Are you sure that you're in a module, a general, you're in like module 1? Is that where you are?
Yeah.
Okay. Hopefully Jaron can get you going. Okay. Function procedures and sub-procedures are exactly the same, except the function procedure sends back a value to where it was called from when it's done executing. Sub-procedure is a bunch of statements. There's a bunch of instructions to do. You say, run this code, and the sub-procedure goes, runs it all. And when it's done, it goes, done. Function procedure is the same thing. It's all the same stuff. But when it's done, it says 7, or false, or Fred. It sends something back to where it was called from. So the first thing to realize is it takes one little bit more of syntax to be able to say, how do we set the return value? It's going to be a collection of statements, just the same way a sub-procedure is, but at some point, it doesn't have to be at the very end, it often is, but at some point we have to say, this function is going to return a certain value. And the way we do it is by setting the name of the function equal to something. It's a weird way to do it. It's the only language I know of that says that's the way you make the function return a value, is by setting its name equal to some value. That's it. So now this function will return true. It doesn't matter what we pass into it, it's just going to always return true. I'll come here to my immediate window. Oh, by the way, you're used to when you're developing a sub-procedure hitting play to run it. Watch what happens if I hit play. All right, choose from all these macros to run. Oh, there's none of them. Why doesn't this one show up here? It's not because it's a function. I think function would still show up here, but for this characteristic of the function. What's the characteristic? It has a parameter. A macro, I have to be able to just say run this without passing it any values. And so because this has a value passed to it, it's not a macro. I can't just say run this. I got to say run this, and by the way, send a string to be worked on. So I can't just run the thing. So I'm going to do this from the immediate window. I'm going to call it. I'm just going to say print, or question mark, is valid ISBN. And then I am going to pass it some text. I'll execute that line, and it returns true. Why does it return true? I told it to return true. It's a very simple function. All it does is say return true. No steps before that, just return true. If I want to change that to false, it'll return false. False. or false. Now it returns false. What if I wanted to return 22? The fact that this is a Boolean, I'm trying to tell it to return 22. It's either going to return true or it'll be an error. If I was a betting man, I would bet on true. Boolean is actually a number. Anyway, it's just 0 is false, any other number is true. If you're going to convert a number to Boolean, 0 would be false, anything else would be true. So if I return 0, by the way, that'll return false. Not that that's important, but just underlying. Just like we can convert between numbers and strings, we can convert between numbers and Booleans as well. Between numbers and Boolean as well. All right, let me go ahead and change this back to true, and let's get down to business. Ooh, the question is, what's the algorithm? Does anyone here know the algorithm? I don't know the algorithm. Fortunately, Wikipedia knows all. Wiki ISBN. International Standard Book Number. Here it is. Oh, look. There's the International Standard.
Hey, look at that. 1970. You're right. That's when it was introduced.
Was it signed on or after January 1st, 2007? What are you talking about?
It says it was introduced in 1970 in the box in the ring. Yeah.
See, I'm pretty smart. Okay. Check digits. 10 check digits. ISBN 10 check digits. Here we go. Here's the algorithm. It looks kind of daunting to look at it this way, but it's not too bad. It says this. Let me zoom in a little bit. I lost my check digits. Errors in use. 10 to 13 conversion. Oh, I went down. I should have gone up. Here we go. All right, so we've got a number right here. Here's the first 19 digits, the first 9 digits. We're trying to figure out what the last digit is. Here's how we do it. Step 1. Just watch it here. The first digit is 0. That 0 is here. The second digit is 3. That digit is here. The third digit is 0. Bing. The 6 is here. The 4 is here. The 0 is here. Do you see that? We then take and we multiply the first digit times 10, second one by 9, by 8, by 7, by 6, by 5. So that's the first step in this, is to say, take that thing apart, look at it character by character, multiply the first one by 10, the second one by 9, the next one by so forth. Let's start off by doing that. All right, so we've got this candidate coming in. In fact, let me go ahead and we'll use this candidate that they've given us here. So instead of sending in some text, I'm actually going to send in their candidate. I happen to remember from the last class that I taught only moments ago that the digit for this is 2. So I want to send that in. And we're ready to get going. Okay, so this is going to call that function. Oh, here's the problem. The problem is I got these dashes in here. Those dashes are a problem. In fact, sometimes I've seen ISBNs written with spaces in the little blocks. Sometimes the whole thing just run together. Sometimes they have dots instead. Well, lots of different ways that we see these written. So first thing, I think what makes sense to do the very first here is to say, let's just get rid of all the characters that aren't really part of the number. If it's not part of the number or the check digit, let's get rid of it. So we're going to make another function. Even before we've just barely started this one, we're saying, listen, as we're building this one, we're going to need something else kind of on our way to this. It'd be great if we had another function that could help. Oh, by the way, I probably should have told you this sooner. What we're doing today, we are writing a function to implement the algorithm for a 10-digit ISBN. Your next project, we should do in a couple weeks, is for you to do the same thing, but not for a 10-digit ISBN, for a 13-digit ISBN. It's going to be the same as this, but a totally different algorithm. So process is the same, different implementation. So what we're about to do will be very helpful to you in that project. Function. I want to be able to pass this to this function we're about to create and I want it to return this. Get rid of that dot, get rid of that space, get rid of that hyphen. In fact, anything that's not a number, get rid of it. And so I'm just going to call it numbers only. I'm going to pass it some data as a string. And it's going to return a string. Now wait a minute, I'm only sending back numbers. Should I return them as a string or should I return them as some numeric value?
String.
Why a string?
Because you're reading. Yeah, the second function only reads string.
Oh, you mean down here?
Yeah.
Oh, we could kind of call it there, but we're not going to.
Could have an X.
We could have an X, but this really is going to return just the numbers. We're going to treat that last digit a little bit differently. There's a really compelling reason to use a string. String is right. I haven't heard the compelling reason.
Because it's coming in as a string.
Not because it's coming in as a string. We can take it as a string and send it back as a number all the time.
Is it because you want to look at each digit in the string rather than individually?
Not because I'm going to look at it. That's why it's coming in as a string. But we're talking about what values this function is going to return. That's the whole point. We're going to get rid of the dashes. We're going to send it back without the dashes. We're going to send it back something that's numeric.
Because you could use like the left and
Okay, so again, that's an argument. Because we want to use left and mid, that's an argument for why this should be a string. With the return value. Take one more, and then we'll quit playing the Sunday school game.
Because I've got to pass a string into my other function, else I'm going to start looking for it.
Nope, not it.
That's what I was going to say.
It's because I've got to pass back that 0 right there. If I send this back as a number, the leading 0, poof, is gone. And so you need that. Yeah, you need that leading 0. And for us, it's going to be critical. You'll see why as we go. Okay, so this is going to return a string. As string. Now, the compelling reason why we would say, no, this should come back as a number is if you're going to do some math with it. Right? You're going to say, take this and take a bunch of the roots of this function and sum them up. Or take the average of these. Remember to do that with ISBN. What's your ISBN times 2? Doesn't mean anything. You're not going to ever sum ISBN on, wow, look at that book list. Look at how that book list sums up. Ooh. So there's really no reason, if you're not doing that kind of stuff, there's really no compelling reason to return as a number. Okay. Okay, this is going to be a pretty good review from the stuff that we did last time we got together. So here's what I want to do. I want to be able to look at all of these characters one at a time and ask the question, is that a number? Is that a number? Is that a number? And if it's a number, that's part of what I want to send back. If it's not a number, I don't send it back. Fortunately, watch this. There's a function we haven't talked about yet called isNumeric. I give it some string. And it returns true or false based on if that's a number. 33 is a number. How about 33 or 3.3? That's a number. How about 33 point? Oh, what do you think? Number or not?
no.
I think that's a number. Yeah, that's a number. How about 3.3 dot? What do you think?
No.
Not a number. How about 3.3a? Not a number. Okay. So it just looks at what you said. Is that numeric? It's looking at a string, and it's saying, could I convert that reliably into a number? And if the answer is yes, it sends it back. Sends it both ways, sends it back true or false. Okay, so here's what I'm going to do. I'm going to dim x as an integer, because I'm going to need to look at these. I'm going to need to look at what comes in one at a time. And so I'm going to use a loop. What kind of loop? I got 3 loops to work with. I got the do loop, the for next loop, and the for each loop. Which should I use? For which kind of for? For next or for each? For each allows me to say I got a whole collection of objects. I want to process the objects one at a time. Do I have a collection of objects here? I don't. I got a string. It's one value. So, but I want to look at the first character, then the second character, then the third character, and so for next is going to be my preferred loop. For x equals, and I got to look at all of, I don't care what's passed in. Whatever's passed in, I got to look at them all. So, how do we ask the length of what got passed in? Len data. If 9 characters get passed in, len data equals 9. For x equals, sorry, it should be 1 to the length. Next. Here, I should just be able to do a debug.print of x and that should print, in this case, what do I have here? 13 digits I'm sending in. So it should print 1, then 2, then 3, then 4, up to 13. I'll go ahead and run this. And, oh no, I'm sorry, it's not that one, it's this one. Numbers only. Print numbers only. And there, print off that. So this loop did just what it's supposed to do. So I'll print that, but now what I want to print is not just X, but I want to print these digits one at a time. I want to print the 0, and then I want to print the dot. So when X is the 1, next to it I want to put a 0. Then by the 2 I want to put a dot. So what expression could I put here to get at a particular element of this string? Don't give me the whole expression, just give me the function. What function should I use? Mid. Take the mid. Looking at my data string, whatever's passed in, starting at the someplace and taking only one character. So I'm going to skip that middle argument for now. Okay, so mid says start at 1 and return the 1 character. Start at 5 and return the 5th character. What do I put here so that the first time this line executes, this evaluates to 1 here, then it evaluates to 2, then to 3. What is it? X. Good, just put X right there. And so now when I run this, it should print off 1 through 13, and it should print off the corresponding character for 1 through 13. Let me go ahead and just clear that off and run this again. Is that right? 0 dot, a little more space here. 0.306, 0.306, space. That looks perfect. Last one's a 2, last one's a 2. We're right on the money. Okay. So now we've got those. In fact, I'm going to go ahead and put that into a variable. Let me create another variable here. I'm going to call it 1char as a string. And so now I'm going to set 1char equal to that. So 1char, 1 character, equals, and then I'll set that equal to my mid expression. And now I'm just printing 1char. So instead of just printing the mid, I wrote the mid into a variable and I'm printing the variable. Follow that okay? Question?
So why you leave 1char as a string? Because only 1 character.
So 1char is a string because I need it to be able to handle that space, as opposed to being a number. So now I've isolated the result of this function. I could do it without putting it into another variable, but this makes the code a little easier to follow. And so I'm going to say I've now got that 1 character, and I want to look at it and decide, is it a number? So it definitely needs to be a string because I got a bunch of things here that aren't numbers. That's the whole point. I'm sending in a bunch of things that aren't numbers. I got to tell which ones are numbers, which ones aren't. Okay, so now I'm going to use an if statement using 1char. If is numeric, 1char, then I got to end if in. I think I'm done with the print right now. So now inside this, I will only execute the code inside this if the 1 character I'm looking at for this iteration of the loop is numeric. So now I just got to have a way to kind of collect the ones that are. Because the ones that aren't numeric, I don't care. I don't need to do anything with it. But if it is numeric, I got to do something with it. So let's just make a way to accumulate those numbers. So I'll just call it temp. Temp as a string. All right. So now each time I find a numeric character, I'll come inside this if statement, and I will say temp equals what it used to be concatenated with 1char, whatever that character is. So when 1char is holding to 0, we're going to say, hey, is it numeric? Yeah, it's returning true. Remember, so I'd have no equal sign in here. That's a little bit unusual when we're first starting off because we're used to seeing if x equals 5, do this. But remember, whatever we have between the if and the then just has to evaluate to true or false. X equals 5 is either true or false, depending on what x is. Is numeric itself is true or false. And so I don't have to say it equals anything. I can just put it here. So when it's true, the first time, when 1char is 0, temp is going to be what it used to be. What did it used to be? Empty string. That's the default value for strings. They always start empty. And we'll put 1char. So at the end of that, it'll just be 0. The next time through the loop, 1char will be the dot. Is 1char numeric? No, so we skip by this. Temp is still just that 0. We come through the loop again. We get to this. Now we're looking at 3. Is one char numeric? Yes. So temp, which is currently a 0, is going to be 0 concatenated with the 3. And so this is going to let us skip by anything that's not numeric and then only accumulate the things that are numeric. That's wonderful. And so now we're done except for returning the value. So now we're going to say numbers only equals temp. And so now if I print numbers only, it should just give me the numeric part of it. Pretty good. Strip away anything that's not numeric. I could put my country, tis, comma, tis of thee. Same answer. All right, look at those individually. Is that a number? Not a number, not a number, not a number, not a number, not a number. It's just my level. I'm not sure we want to look at that and say that's a valid ISBN, but that's according to our rules. Throw away all the numbers and then we're in good shape. Go ahead, question.
So, what is the value that temp start with? Is 0?
Temp starts with not 0, it starts with an empty string. Anytime I declare a variable that's of type string, it gets initialized to have an empty string. It is just as if we had this, temp equals quote, quote. That happens automatically when the variable is declared. That's not true in a lot of languages. A lot of languages, you allocate a variable, you say, oh, there's some memory over here. There's a bunch of 1s and 0s there already. Whatever they are, that's still what's there. Whatever was there before, that's still what's there. But in VBA, it says, you make a variable, we're going to wipe that out. And you're going to start off empty. If it's a number, whatever's there in memory, we're going to wipe it out, and we're going to start with 0. So numbers start at 0, Boolean starts at false, and integer strings start as empty. Other questions? Okay, now that we've got numbers only, let's get down to writing this is valid ISBN. So I think step 1, once we get in here, let's do this. Let's declare a variable. I'm going to call the variable ISBN. We've got the candidate that we're working with here. I'll declare ISBN as a string. And let's do this. Let's say ISBN equals, I'm going to call numbers only, but I'm not going to pass it the full candidate because that very last character, we're going to assume the last character is the check digit. We'll throw away hyphens and spaces if they're in the middle of the ISBN, but not if they're at the end. And if you give us a hyphen at the end of this, that's not valid. We're going to assume that last digit has to be the ISBN. So we'll take numbers only, and we're going to send it everything except the last character from what gets passed in. Why do we want to send it the last character?
Because that's the check digit.
Well, check digit's okay almost every time. But what's the condition when we don't want to send the check digit over?
What's an X?
When it's an X. If that check digit's an X and we send it over there, it's going to come back, we'll strip that X out. So let's do this. Let's send everything but the last character. Oops. Function. Candidate.
You spelled numbers only wrong.
This is okay. I'm wondering why the top one is.
Because the top one has.
Oh, yeah, thank you. Thank you. Okay. Got rid of the whole name. Okay, ISBN numbers only. How do I send everything but the last character? The left of candidate. And I tell how many characters. If there's 13 digits coming in, I want it to be 12. Obviously, I can't hard code that. How do I ask how long it is? Length of the candidate. Minus 1. And then close the parenthesis off for the numbers only. At the top, you've got to make sure you got all the right plans. We've got 3 opening, 3 closing. We're looking like we're in pretty good shape. And hey, while we're at it, why don't we do this? Why don't we concatenate on the uppercase version of that last character? The right of candidate. So we're taking the whole candidate. We're saying, let's take that rightmost character, and let's set it over here. Is that the right to you? No. Let's take the rightmost character, and let's set it off here. And then let's take everything else, send it off to numbers only, and then drop it. I'm going to put a breakpoint right here on end function. And I'm ready to call this and just check to make sure that ISBN is what I think it should be right now. So when I pass this in, ISBN should look exactly like what we've seen here already. I've got a breakpoint here. I'm going to run this by hitting enter in my immediate window where I'm saying print the results of this function. So function not defined, N-U-M-B-E-R-S.
You spell it numbers at the top.
Yeah. Turns out it is not spelling sensitive so much as it is just has to be consistent. No, it's right here.
The most common mistake is the transposition of two sequential.
Well, that's right. That's the most common error. N-U-M-B-E-R-S.
It's right there. It's not right up.
Up here, N-U-A. Okay, so I had it right. I had it right. I'm going to do it in both places. Okay, let's try it again. There we go. Okay, so now I haven't finished running this. I'm stopped right here, but I should be able to come in here and probe what the ISBN is. Yeah, so it's got the same thing. Okay, let me go ahead. I'm going to stop this. Let me go ahead and pass it an X. And we'll make sure that X comes in. And because I'm uppercasing it, this X should now show up as uppercase when I run the function. I'm suspended here. I'm in break mode, so I can now kind of query these variables that are declared in here. That looks pretty good. Now I've got the whole thing just with the X instead. Wonderful. Okay, so I feel pretty good about this. So at this point, I'm ready to start kind of taking some punches at this candidate ISBN. What can I do at this point and say, you know what, I don't have to see anything else. This ISBN is not a valid 10-digit ISBN.
The count?
Count of?
Of the ISBN that you have.
How many digits? Mm-hmm. The length of the ISBN. If it's not, at this point, if my ISBN isn't 10 digits, it's not valid. I don't have to see anything else, right? So let's just go ahead and do that. Let's just say if ISBN, if the length of ISBN is equal to 10, then that's if it is equal to 10. I want if it's not equal to 10. I'm going to put a not in front of this. If not length of ISBN is 10, then exit function. All right. So if I exit the function, I'm never going to tell ISBN to be anything. What is ISBN going to evaluate to? If I don't ever set it to true or false, what will it be?
False.
Yeah, it will be false because the default value for all numerics is 0. The default value for strings is empty string. The default value for Boolean is false. And so if I never tell it to be true, then it's going to return false. So that's a simple way to do it. If it's not 10, if the length's not 10, get out of here and it will return false automatically. All right, what else? Could I look at this and know immediately it's not valid? What can I do to look at that check digit and know this is not valid? What do I have? What condition does the check digit have to be at this point? There are 11 symbols it could be.
So it has to be 0 through 9 or X.
0 through 9 or X. It has to be a number. It's only one character, so it has to be a number. 0 through 9. I can just ask it with numeric, or it has to be X. So let's do that. Let's say if the right of ISBN, comma, one character, is numeric. So let me go ahead and put this in as is numeric. Or the right one is equal to capital X, then, and again, this is the condition when it's valid, so I'm going to not this whole thing. Because I've got two different conditions in here, I'm going to go ahead and put parentheses around this to make sure that the not doesn't operate just on the first half. I'll put parentheses around that to make sure all that happens first, and then the not. So if this, then we want to exit the function. Okay, So we're able to have a couple of quick checks and just say, listen, if it's not 10 digits, and if that last character is not either numeric or an X, it can't be valid, get us out of here. So if we get here, this part's really nice. If we get here, we know that we've got 10 digits to work with. That's going to be helpful to us. Now we know we have 10 digits, because if we didn't have 10 digits, we wouldn't be here. All right, now I'm ready to implement the algorithm. Oh, we got like 7 minutes. We'll do it a little bit quickly. You may need to watch the video. Fully grasp what I'm about to say. Let's do, remember we're going to do a variable, a loop, very similar to the one we did for numbers only. Numbers only had to look at every single character. We've got to do the same thing here. Dim x as an integer, and we'll have a for loop down here, where x equals 1, 2, and what we can do here, we can just say 1 to 9. We know the length of its 10 digits. Our algorithm says, do this with the first 9 digits. So 1 to 9, that'd be great. Let me start off by printing these out. Debug.print x, comma. Now, I need x, and I now also need to get at each one of those digits, same way we did it before. Mid of ISBN, starting at the x position and taking 1. And then let me also print this other sequence. I've got to get a 10, a 9, a 8, a 7, a 6. Well, my x goes from 1 to 9, so if I just come in here and say I want this to be 11 minus x, that's going to give me that series of numbers. When x is 1, 11 minus 1 will be 10. As x goes up, this expression goes down. So now I am going to just drag my current position indicator up to the top of my loop. And I'll run that again. But this time it should print a bunch of stuff off into my immediate window. Okay, so here's my value for x, 1, 2, 3, 4, 5. Then here's the characters I'm working with, 0, 3, 0, 6, 4, 0, 3, 0, 6, 4, 10, 9, 8, 7, 5, 6. I've got the numbers that I've got to work with. 0 and 10, I've got those on one line. 0 and 10. 3 and 9, I've got those right here. 0 and 8, I've got those right here. You see it? Now you guys are used to working in Excel, where you say, I've got all these numbers, let me just do a sum product on these, and I've got it. But here, these exist only momentarily while each line of this is iterating. And so I'm going to have to do something to kind of accumulate this as I go. Let me declare another variable. Dim, I'll call it my checksum. Checksum as an integer. Integer will be big enough for what we're doing. I'm declaring a checksum as an integer. And now I'm just going to do the math right here. Checksum equals what it used to be. It'll start at 0. Plus, and then I need these two expressions just multiplied by each other. I'll change the comma to a star. Make sure that this math happens first before the multiplication. That should do it. Now, it turns out mid is going to return a string. And we're going to try to do some multiplication with this. It's okay. VBA is going to look at this and go, well, that's a string, but it looks like a number, and it'll do the conversion for us automatically. We don't have to worry about forcing that to be an integer. So let me move my, I should have done that above the debug.print. We come down from debug.print and then just add checksum onto this. And bring my current position indicator up here again. And I'll run that loop again. And so now I can see myself building that checksum as we go. It ends off at 130. That is exactly what we're supposed to get for this particular example. So far, so good. So we've got really the heavy lifting done from the algorithm. We've added up all those values. We've got to the 130. There's some more steps we have to do to it. That's coming up next. But I want to make sure you've got this part here. Any questions? Okay. Next step in the algorithm, come look at it down here. It says we're going to take here's that step that we had right there. Oh, we had it right here. Here's the 130. We take that 130 and we mod by 11. Right? Divide by 11 and take the remainder. So after we're coming out of this loop, I'm just going to say, all right, I don't need the 130 after this, so I'm just going to kind of make these changes into the same variable as I go. Checksum equals checksum mod 11. That's the next step. Great, that's going to be 9 in this example. And then we take 11 minus 9. So now we'll do this again. Checksum equals 11 minus the checksum. That's going to give us the 2 right here. And then we do mod 11 again. And that's it. I'm going to stop this because we're kind of accumulating checksum and run the whole thing again up to here. And hopefully we've got the 2 that we see in the example. So if I look at what checksum is, yeah, checksum's 2. So we've correctly done this. Now we've got it. We're almost done. We've calculated what the check digit should be. Now we just have to check to see if that's what the check digit is. So let's just do it in an if statement. If our checksum is equal to our check digit, the right of ISBN, comma 1, then what does that mean? Yeah, then we should return true. Well, that's what we got right here. Return true. Take that check this checkpoint off. All right, stop the flip. Okay. Then it's true. Okay, we got something else. We have something else to check. Else if what? Yeah. Else if checksum is equal to 10. And the rightmost character of my ISBN is equal to capital X. We've already converted to uppercase when we first brought it into check digit because we did a U case of the rightmost one character of the candidate. If that's the case, then else if, no space, else if, then also true. I don't think there's anything to consider. Else, it's got to be false. I don't even really have to have the else here because it would have never hit those 2 true, so it would have to return false because it never said it was true. I'd like to see the false in here because now I can look at this block here right at the end of my function and I can say these are mutually exclusive blocks. I'm going to hit one of these things. I'm going to say, this will be true, this will be true. Otherwise, it would be false. Kind of isolates where I have to look to find out what's it going to return. Without having the else it equals false, I got to look through the rest of this and say if there's something else that could be setting this to be false or true. So that should be it. So if I check this one, this should be false. If I change that to a 2, that should be true. Beautiful. The last thing that I want to show you is that we can also, now that we've got this function made, here's one of the beautiful things. We can do this in a cell. This equals is valid ISBN. We're going to pass it what's in A7. Now let's actually put a value in A7. See how well that worked? Oh, there we go. So now that's true. We change this to something besides the proper check digit, and it goes to false. So one of the great things about building this function in VBA, we can use it from inside a worksheet. Oh, it's a miracle. Oh, it took 1 minute longer than it was supposed to do. But that's it. Any questions? I'll go back to the code. No, that's always a question. All right, class dismissed.